In this video I'm going to discuss reducing fractions, and we'll be using prime factorization, which was what we talked about in the last video. A couple of properties that are important are the associative property of multiplication. We'll use this to group factors differently. The associative property says regardless of how you group your factors, you get the same product. And we'll also be using the multiplicative identity, which is the number 1. We'll use this idea that if you multiply by 1, you get the same value you began with a lot in fractions. This is like the foundation for everything we do. A fraction's reduced when the only common factor in the numerator and denominator is a 1. For instance, 610 isn't reduced because both the numerator and denominator share a value of 2. But I'd like to just discuss for a second why reducing works. And that is, if you look at the prime factorization of 6 and 10, you'll notice that we have 2 divided by 2. If we regroup this as 2 over 2 times 3 over 5, then 2 over 2 being 1, this is really just 1 times 3/5, which is 3/5. So once we get our numerator and denominator prime factored, we can reduce any factors that are common until there are no more common factors. In practice, what we're going to do is start with something like 6/10, find the prime factorization of both the numerator and denominator, reduce common factors. 2 over 2 is just 1, and then 1 times 3/5 is 3/5. One thing that you have to be a little careful of, sometimes after prime factoring and reducing, you'll notice that there are no factors left in the numerator. Occasionally people come to the misunderstanding that there's a 0 in the numerator since all the factors are gone. Keep in mind that we're always reducing to a factor of 1, so this really does reduce to 1/2, not 0 over 2. Here's the procedure we're going to use to reduce fractions. You're going to prime factor the top and bottom, reduce common factors, and then multiply any remaining factors together. You can't use the Gazinta method. And what's the Gazinta method? It goes like this. You'll start here and someone will say, well, 5 goes into 120 24 times, and 5 goes into 45 9 times, and 3 goes into 9 3 times, and 3 goes into 24 8 times, and it's 8/3. That's not what we're going to do. What we're going to do is more like this. 18 is 2 and a couple factors of 3. 24, 3 factors of 2, 1 of 3. Reducing the 2's, reducing the 3's, and the factors we have left give us 3/4. Try this one. The prime factors of 90 and 63 are what I have here. The 3's reduce, the other factors of 3 reduce, and we end with 10/7. Here's another one. In a case like this, I just worry about prime factoring the 120 and 45, and I don't worry about the sign. It'll just stay with us till the end. Here are the prime factorizations, taking out the common factor of 3 and 5, and multiplying gives me the result -8/3. How about this one? In this case, I have these prime factorizations. There's a common factor of 3 and 7, and that leaves us with 8 in the numerator and 15 in the denominator. Next, we're going to use the technique we've just practiced to help us multiply and divide fractions.